Hello and welcome, everyone. We are live. We are celebrating Healthy Soils Week. Thank you so much for joining us. I am Lauren Snowden. I am the statewide training coordinator for the UC Master Gardener program, and I am happy to bring to you a very great event. We are talking with Mike Corby. He is a UC Master Gardener in Contra, Costa County. And, a lot of us UC Master Gardener volunteers know a lot about things, and Mike is a soil person. So we're very happy to have Mike here to talk about healthy soil. In nature, sometimes less is more. I know a lot of us want to do everything we can to improve things, and Mike is here to tell us a little bit about how nature is taking care of the soil for us and how we can assist with that. Mike, so far we have about 20 people joining us live. So, do you want to say anything? Do you have a shout out to any friends that you invited to come watch? I know I invited my mom. So, mom, if you're on, hi. It's always a good time live.
Yes. Well, thank you, Lauren. I appreciate the opportunity to spend a little time talking about soil. I'm a little passionate about it myself, and so I hope that perhaps I can share a few insights and give people maybe a little bit different perspective on their garden soils.
That's great. Okay, we're up to about 30 people live, Mike. So why
Okay.
don't you go ahead and share your screen for us?
All right.
And just so everyone knows the format, we're doing about a 30-minute talk and then we'll have 10 to 15 minutes for questions. You can drop your questions in the comments. I'll be moderating them throughout and feeding them to Mike afterwards so we can get some of those answered for you. Thank you so much for joining us. If you are a UC Master Gardener volunteer, this does count as continuing education. So make sure you type it into your volunteer management system hours so that you can get credit for this. Oh, we have more people joining us. This is going to be a great Healthy Soils Week. It's all week. We have lots of events between the UC Master Gardener program and some other, what is it, CDFA, some USDA activities. So, okay, Mike, I see your presentation. I'm going to go ahead and add it to the screen. All right, we are seeing your title screen, Healthy Soil. Mike, take it away.
Great, Lauren. Again, thank you, and thank you everybody for joining this morning. I hope that we can have a good half-hour talk here, and hopefully we'll stimulate some new and interesting thoughts for you about the soil in your garden. So, healthy soil is an interesting topic. It's one that's gaining a lot of more attention, both in the big ag sector and in our gardens. And so, what I would like to do today is actually cover two topics, if I can, in this brief time. But the first topic is, what is soil? A lot of times, I think we rush off to try and fix or improve things, and not really understand what it is that we're dealing with. And so, the second half of the topic will be maintaining and enhancing soil health. And specifically here, we're talking about garden soil. We're not talking about container plants or other types of soil. We're really talking about the soil that is typically found in your garden, whether you're using raised beds or planting directly in the soil. So that's really what this conversation is going to focus on. So I always like to start off with this picture. This is a beautiful picture of a mountain range in the Colorado Rockies. I just want you to kind of look at it for a second, because this is obviously a very healthy ecosystem. And the important things that I want you to think about here are, this has never been tilled. No one's out there with a plow or a shovel turning the soil. There's no fertilizers being used here. There's no insecticides, no pesticides, no fungicides. So this is managing to thrive independently of all of those things that we as humans sometimes think we need to do in a garden to make our garden healthy. So to kind of put that in perspective, okay, the earliest land plants evidenced that we can go back in archaeological history and find occur about 460 million years ago. So that's when plants and soil started interacting together. And yet evidence of the first modern human beings only dates back to about 43,000 years ago. So if you think about it, the plants and soil have been around interacting with each other about 10,000 times longer than people have been wandering the earth. Okay. And during that time, that 42,000, 43,000 years ago, to only about 12,000 years ago, human beings subsisted off of what we got from the soil, either directly or indirectly. We were hunter gatherers. And then about 12,000 years ago, I'm sure some old guy like myself decided that he was getting tired of hunting and gathering and decided he was going to plant himself a garden. And so that was when um, agricultural age actually came about. And so we went on happily growing things in our garden for about 8,000 years and decided at that point we needed some tools. So at that point, the evidence is that there were probably plows and what we call sometime between the Bronze and the Iron Age, about 4,000 years ago, that we started using tools to help us in our gardens. And then we actually were able to synthesize fertilizers, not natural fertilizers, but chemically produced synthetic fertilizers only about 185 years ago. So when you think about it, our involvement with plants and soil it really hasn't been that long. And things have actually gone along pretty well all by themselves. So when you look at this field here, what do you see? Well, it's kind of hard, huh? I mean, we see it's got some top cover on it, but it's really difficult to see what's going on with the soil. And I kind of try and liken this to what it would look like if we were out on a boat in the ocean or a very, very large lake. It doesn't really look like much is going on here. But if you're in a part of the world with a healthy ocean or a healthy lake environment, right? And we got into our submarine or we put on our scuba gear and we got below the surface, we'd probably see something like this. This is a very healthy ecosystem that's going on under the ocean. We've got plants and we've got animals, and all these are interacting. They're all working together to create a healthy environment. And if we could do the same thing with soil and we could drill down into the soil, you'd probably see something like this. Soil is an ecosystem itself. And what you have is you have plants on the surface of the soil that are pushing roots down. Below that, you may have small mammals. We've got insects and worms and things of that nature that are going on. If you go a little bit deeper, you might need a microscope to see this or a powerful magnifying glass. Things like mites, nematodes are interacting here with the roots around the soil. And then even farther down, you're going to see things like fungus and bacteria and protozoa. And all these are working together. These are all working together in this ecosystem that we call soil. So soil has a lot that's going on. And that's kind of what I want to talk about for the first half of our discussion here this morning. So what is soil? Well, basically there's four components of soil. There's minerals and organic matter. Then there's water and there's air. And if you look at this pie chart, you'll see that there's kind of an up and a down arrow with water and air. So for a lot of us right now, we're coming into the winter months. And so if we get into hopefully get out of this drought and into a rainier season, that water percentage may go up a little bit, or at least come back to 25%, depending on where you're living in the state. And the air may decrease. In the summertime, when we have less moisture, those two may change a little bit as well. But they're kind of interactive. But the important thing here, and something that a lot of people I don't think realize, is that when you look at soil, it's 50% solids, 45% minerals, 5% organic, and it's 50% what we call pore space. So the solids part of it helps anchor our plants to the soil. But that pore space is very, very important because it's that open pore space that allows the roots in our plants to really get down into what they need to find nutrients. So this is very important that when you think about these things, that in a healthy soil environment, this is what you're kind of trying for. Now, this is the optimal. And of course, there's going to be variations to it, but this is how I want you to kind of think about this as we talk about it this morning. Okay, so we look at a healthy field. I mean, we're very blessed in California. We have a lot of fertile soil out here. But what does that really mean? So typically, what I say when we talk to other folks at farmers markets, other places, that if your plants are thriving, then you have a healthy soil environment. But again, what does that mean? Well, we know that plants produce their own food through photosynthesis. Um, but plants can't produce everything that they need. Okay, so they actually derive more nutrients from the soil. And we'll talk about that a little bit more here. So plants need nutrients. Basically, from what we understand today and the research that's going on, there are 17 what we call plant nutrients that plants need beyond what they can produce from photosynthesis. And these nutrients are really there to help them with photosynthesis, for the process of photosynthesis, and for the ability to build cells and other things that plants do to grow and produce fruit and to be able to reproduce. So if you look at this, we kind of break it out into two parts. There are macronutrients. These are the things that the plants use the most of. And then we have what we call micronutrients. Now, these aren't any less. Your plant needs every one of these just as much as it needs any of these. It's just that they use these in smaller quantities. And of the macronutrients, you can see that the three big nutrients that plants use, this makes up about 95% of a plant's structure. Carbon, hydrogen, and oxygen come from air, come from water. Okay, but from the soil side, actually 14 of these nutrients come from the soil. Okay, and they come from what we call mineral soil. So what kind of does that mean? So remember with this pie chart, we talked about the fact that 45% of soil is minerals. So what is a mineral and why is that important? So if I go back to this picture for a moment, minerals are stored in rocks. So as rocks formed, as the earth formed, elemental elements, so those things that we looked at, those 17 essential elements that plants need, are locked up in this rock. And over time, this rock goes through a process called weathering. And so as it's weathering, it's breaking down. So freeze thaw, temperature, expansion and contraction, wind, rain begins to break this rock down into smaller and smaller pieces. And as that begins to erode off of there, it moves down through gravity and it begins to gather in low spots. And that's typically how topsoil is built. And over time, and this takes a very, very long time to happen for that rock to break down, it could take from 500 to 1,000 years just to develop 1 inch of topsoil. But eventually that breaks down into our soil particles, the clay, the sand, and the silt that's in our gardens today. And that's what you see here. That is just that rock decomposed down into now soil, what we call topsoil. And so in this particular case, this is teeming with a lot of nutrients and a lot of elements, all related to that original, what we call parent material from that rock. Now, I just want to stop here for a second, take a quick look at this and explain something that soil is not. Okay, and you're going to see a lot of this. If you're in big box stores, if you're in nurseries, you're going to see packaged like this. And I'm not taking anything away from any of these particular products. I think they're good products and I think they're great, which is another whole topic about amendments. But you'll notice that each one of these say soil. But just like when you're being a good consumer in the store and you look on the back of a product and you read the ingredients label, I encourage you to look at the ingredients labels on these products, because what you're going to see is they are not 45% minerals. Most of these are made from what they call forest products. In this particular one here in California, this product is formulated with compost, processed forest products, and sphagnum peat moss. Okay. In Georgia, this product is 85 to 95% processed forest products. So I'm not saying that these are bad, and they're certainly great if you're using containers, but they do not contain minerals, and therefore your plants can be stunted. They're not going to thrive if they're living in this kind of an environment. So let's continue on. So we talked about the mineral component of it. The other piece of it is organic matter. That makes up about 5% of your soil. Okay, it doesn't seem like a lot, but if you've ever baked bread, it doesn't take a lot of yeast, which is the organic component of bread, to make a loaf of bread, but it magically transforms flour and water into food. And organic matter here has a huge role in converting what we would consider just minerals, or if you want, dirt, into soil. So let's look at that for just a second. So, what is that organic matter? Well, it kind of has a few components to it. It's about 15% of it is living organisms. Those are those bacteria, the fungus, the amoeba that are in that soil, the insects and the worms that are in that soil. All of them living together in this environment that we were talking about. This fresh residue, that's material that is sitting on the top of your soil right now, breaking down. This is a great time to think about this because in the fall, most of us got leaves all over the garden. And that's an important part of it because that is what we call fresh residue. That is what's going to start breaking down into this component here, which we call decomposing organic matter. So all of that bacteria, the fungus, the earthworms that are in your soil are coming up and they're actually feeding off of this material and they're breaking it down. And as they break it down, they're also breaking down those minerals and they're converting the mineral materials, those essential elements that we talked about, into a plant available form. Right now, those minerals, when they're originally in the soil, are not available to plants. They need to be converted. They need to be what we call mineralized. And at that point, then a plant can take those minerals up and use it in its development and its cell building. And then below that is what we call stable organic matter. So this is material that has been decomposed to a state where it's very stable now. It's not going to change much more. But this is critically important when we talk about that pore space. This is what helps soil begin to hold together. And that's a very, very important consideration in your soil. You want that soil, as you're building the soil, you want it to stay in place. And what we call that is soil aggregates. And this is a very, very important component of aggregates is stable organic matter that allows your soil to hold together so that it can hold those minerals and it can hang on to them. And so these are very, very important in terms of the fact that once the minerals have decomposed and mineralized and are available, you want them to stick around. You don't want them to leach out of your soil as we have going through this rainy season or as you irrigate in your garden. You want those minerals to hang around. And that's what this stable organic matter does. It helps to actually allow those minerals and those elements to cling to the soil particles. So what does organic matter do? Well, as we increase organic matter by adding things like growing crops in our soils or adding any type of amendments to the soil, compost or manures, even the leaves that are falling right now, all those are increasing the biological activity within your soil. And that goes on to do a lot of things, okay? One of the things it actually does is it reduces soil-borne diseases. So things like parasitic nematodes and other parasitic funguses or bacteria that can get in the soil. This actually protects your plants against that. And then from the decomposition side that we were talking about, it actually cleans up harmful substances that can be in there. Nutrients that we talked about are getting released. That aggregation, holding that soil together, is increased. We talked about that. Another word for that stable organic matter is called humus. I'm sure you've heard about this if you've been gardening for any time at all. That helps with growth promoting substances in your soil. But all of these working to improve that pore structure that we talked about. And also it helps with water storage. Significant ability for water to actually be held on by your soil which is so very, very important when we're in a drought like we are here in California. So, we continue around on this and defining what is soil. About 25% of soil is water. A lot of times when we think about water in a garden, this is what we think of. My plants are drooping and I'm adding water so that they perk back up. Well, that's not exactly wrong. There's nothing wrong with that. And actually, water pressure within the plant walls is what does help make a plant stand up. But water is so very important to your soil in other ways as well. So let's just talk about those really, really quickly. So in your soil, water is called soil solution. Okay. And there's some reasons for this. Water actually creates a bridge. The properties of water, its ability to kind of stick to things, actually creates a bridge. So it creates a bridge between soil particles and your roots. And so what that does then is as those elements dissolve, they can actually then be transmitted from the surface of the soil particles, that clay, sand, and silt, to the roots where they can be taken up by the plant. Okay, and water is a very interesting molecule in the fact that it doesn't really change its properties as things dissolve into it. So many things can dissolve in water, and that is what really creates that bridge, that ability for those elements that are so important to actually get into the plant. Okay, and then just like we as humans, those organisms in your soil require water as well. So water plays an important role. And then the other one, the fourth component here that we were talking about is air. And air is very important. Obviously, it's important to us. That's how we continue to live. But this is kind of how air breaks out. It's about 78% nitrogen, 21% oxygen, and then small percentages of carbon dioxide and some other gases there. Okay, but we mentioned that nitrogen is a macronutrient for your plants. But nitrogen, as it is in the air, is not available to plants. It needs to be fixed. And so those bacteria in your soil actually can take nitrogen and they can convert it to a plant available element. And so even though there's lots and lots of nitrogen around and it's an essential element to your plants, it needs to be fixed. So it's the nitrogen that's in your soil that then the bacteria take hold of and actually convert it in a way that makes it available. And then the other thing, we often think about plants and we think about carbon dioxide, but carbon dioxide is used for photosynthesis. But in this particular case, again, the roots need oxygen, just like we need oxygen. And also the soil life needs oxygen to continue to live. So these are very, very important parts of, again, the whole soil makeup. So plants require oxygen. We mentioned that. Living organisms require oxygen. It's an important component of the soil nutrients, the nitrogen that's in there. And as I explained before, excess water will displace soil air. So it's important that you don't overwater. You kind of want to think about your soil. If it's adequately watered, it's kind of like a wrung out sponge. It's moist, but it's not sopping wet. And that's kind of where you want to be. So if we were to take this and we just sort of put it into a cycle, it's what we call, a lot of soil scientists call this the nutrient cycling. And this is kind of taking it and looking at it as a continuous ecosystem. So if we start up here with the mineral component that we talked about earlier, that's where the essential elements come from. They come from the minerals that are in your soil. Those minerals are not in a state that your plants can use. So the organic matter in your soil, the bacteria, the fungus, and many of the other decomposers that are in your soil begin to convert those elements into plant available form. Once those elements are available and they're in the soil now as an available element, water can help carry those from the soil particles to the roots where the plants then derive their nourishment. And importantly, at the end of life, whether it's the plants themselves or whether it's any of the other living organisms that are in your soil, when they come to an end of life, okay, those essential elements that they took up that they internalized actually become available again. So they a plant that has come to its end of life still contains over 30% of the nutrients that absorbed while it was actively growing. So it's very, very important that you think about that we want to return those to the soil because that's how we keep this cycle going. And that's part of what is healthy soil. So, what are the keys to healthy soil? Well, one of the things that we talked about earlier when we looked at this particular diagram is well, this is an ecosystem. Okay. And within that ecosystem, it's important not to disturb it too much. For years and years and years, we thought it was very important to take a tilling process, maybe double digging, maybe tilling it with a small rototiller. And there are times when you need to do that. When maybe you're just starting out, maybe you just purchased a new home and the soil is just like a parking lot, and so you need to get some of those organics in there. You need to get some of that air and allow the water to penetrate that soil. So maybe one time you need to get in there and do some heavy tilling. But after that, once this system is in place and it's beginning to thrive, you want to avoid tearing this up because you can see the damage that can be done by it. And then it takes a long time to restore it. Okay, another thing you want to think about, and this is part of disturbance, but whenever possible, you want to leave roots in the soil. Okay, so what we're saying here is that it's the end of summer and your tomatoes are coming to an end, or perhaps you have an organic, not organic, but an ornamental garden, and the flowers are starting to come to the end of their life cycle. Just cut those off. Cut the plants off at the stem at the soil level. Leave those roots in the soil. Those roots are organic matter, and so you are in essence putting compost directly into your soil. So this is an important part. It also helps stabilize your soil and hold it together, and it continues to feed those living organisms in your soil. And then the other piece is soil compaction. Compaction is an important thing to think about here because we talk about half of soil is pore space. And so in this particular case, you want to maintain that for its ability to allow your roots to get as deep into the soil as possible. So avoid putting heavy machinery on your soil. Try not to walk on it too much if you can, because those are very, very important points in terms of keeping the disturbance down as much as possible. Another thing to think about is biodiversity. If you think about what's going on in nature, there's very few instances of what we call monocrops, where only one thing is growing. So as you think about your garden, whether you're growing plants for ornamental sake, flowers and things of that nature, or you're growing food in your garden, tomatoes and other edibles, use a diverse palette. Think about it that way. And so what that's going to do is it's going to encourage biodiversity, biological activity. When a plant photosynthesizes, it creates carbohydrates. The plant only uses 50% to 75% of those carbohydrates for itself, for its food. The rest moves down through the root system as what we call exudates. Okay, and it's those exudates that are drawing in, especially the microbial activity, the fungus and the bacteria. They love to feed off of that. Okay, and in turn, they're doing things for the plant by breaking down essential elements. So the more types of plants that you have in the ground, the more diversity there is in exudates, and therefore the more diversity you have in your microbes. Also, lastly, diversity aids in slowing down pests and soil-borne pathogens. So both pests in your garden, insect pests and things of that nature, and soil-borne pests, different pathogens, typically tend to be focused on a plant family. And so in that one case, if you're planting all one thing in your garden, then it's kind of like letting a wildfire go. It can just spread very, very quickly. But if you have different plants in between each other, then they act as little walls, little blocks that are going to stop those pathogens from moving as quickly through the garden so they can be less impactful. So These are very, very important reasons why you want to have a biodiverse, real diverse garden. Okay, maximizing living roots, such an important thing. Roots are so important to soil. As I mentioned, I mean, some roots can go down very, very deep. Um, some of your cereal grains, rye and oats and things of that nature, can go down 4, 5, 6 feet. Think about something like a daikon radish can go down 4 or 5 feet. And when this plant dies, all that organic material is there. Many of the grasses that grew wild in the plains and that you still see some in some areas can have up to 300% more biomass below the ground than they do above the ground. So this is really, really important when you think about how do I get organic material into my soil without disturbing the soil. This is a great way to do that. And obviously they're returning those nutrients as roots die. The nutrients that they drew up are going to be returned to the soil. And I mentioned that the roots are a main source of food for the microbes in your soil and ultimately are going to increase the organic matter in your soil. So the next step here to think about is maximizing soil cover. If you look out in nature, when you have soil, soil is rarely bare. And so what you want to think about doing here is you want to maintain plant growth throughout the year. I know a lot of times, and before I became a master gardener, I would finish with a season and I would take the plants out and I would let the soil rest. But I kind of now have more of the opinion that resting the soil is a myth, and it's sort of like saying, "Well, I'm gonna rest my stomach for a month." Well, that might help my stomach, but in terms of the rest of my body, it's not doing any good at all. So if you're working hard to increase the organic material in your soil, the biodiversity of the soil, and everything else, you want to keep that going. And so one of the best ways to do that is if you're not going to be growing any particular crop in your garden over the winter, say, look into cover crops. Cover crops are amazing. They're also sometimes referred to as green manure because they're a great way to fertilize your soil, great way to maintain the biodiversity and the microbial growth in the soil. But they can also do things like legumes are very good at working with bacteria and fixing nitrogen in your soil. Cereal grasses, rye and oats and wheats, very, very good at going very, very deep into the soil and bringing nutrients that may have leached down deep back up into the area of the soil where most of your plants are getting their nutrients from. So cover crops are wonderful, and you can just take them and cut them down and put them right on top of the soil. They will decompose and they will act just like a living compost on the top of your soil. And then lastly is armor your soil. So important. Make sure that you've got mulch or something on the soil. Not only does it decrease evaporation of your soil, but it helps protect against erosion of your soil, which can be so important, especially as we sometimes get into these very, very rainy seasons. You worked hard again to build healthy soil, and it's a shame to have that get washed away. And so protect your soil. You're working hard to make it better and better and better, and you want to make sure it's going to stick around. So, and then lastly, to the extent possible, you want to avoid chemicals in the garden. Okay, that little slide that we show of the ecosystem there, that's a pretty delicate balance. And really, as I had mentioned before, plants and soil have been working together for a very, very long time. And they've been doing it without fertilizers and without pesticides and fungicides and herbicides. And so that's very, very important. And the other piece of it here, especially when we're talking about fertilizers and that we're talking about synthetic fertilizers, is that from your plant's perspective, it doesn't know the difference between an organic fertilizer and a synthetic fertilizer. To them, it's still those nutrients. And so in that particular case, a plant can start to become lazy. So it's kind of like thinking about eating junk food versus eating good food. If we all sat around and ate nothing but junk food, we'd all probably be about 3 feet tall and weigh 200 pounds, because it's just an easy, quick way, right? But that's not exactly how humans are supposed to develop. And so, in the cases of plants with too much uh, synthetic fertilizers, they can become lazy. Their roots will not go as deep into the soil because they're munching right off of that fertilizer that's on the top. There's also a lot of things that we don't have time to get into here this morning, but that affect the chemical composition of your soil, and that those things can be disrupted by adding these chemicals to it. So, just some things that I want you to think about, and hopefully that makes sense to you. Um, I want to thank you for your time, and here's to your and your soil's good health. And I'm open to questions.
Great. Thank you so much, Mike. I really do appreciate that as I'm listening to you, I'm hearing things I can do better, and I'm hearing things that I'm already doing that I feel good about. So thank you so much.
You're welcome.
I don't feel like a terrible gardener, but we just raked up a bunch of leaves, and now I'm like, oh, I should put those on top of my vegetable garden so all the little worms can eat that. So
They'll love it.
I am going to move some of my dead leaves over there so that I can feed my soil. So thank you. I do have good news and bad news. Good news is we're still streaming to YouTube, but our Facebook link broke. It says that
Uh-oh.
that Facebook is not working for us, so we ended part way on Facebook, but we're still live on YouTube, and we have people that are still with us. So, our YouTube folks, would you like to ask any questions of Mike? Mike, I did have one comment. Your analogy of the soil and the ocean really brought it home for me.
Oh,
Um,
good.
yeah, so it for me, I was like, oh my gosh, yes, if I could dive into the soil, this is what I would see. And then I got kind of creeped out that there's all those other, lice and bacteria and other things, but I get creeped out in the ocean. So it makes sense that for me, it's just lots of little things all around me at all times. So I really like that. And your other analogy was the yeast and bread. Totally worked for me as well.
Good.
So let's see. I'm looking for questions. We don't have any yet. Let's see. Oh, we had someone join us from San Bernardino County. Wow, we're getting people from everywhere. Oh, we had Penny from Napa County. She goes, I like to say dirt is not soil. A lot of people say that, Penny. Thank you.
Dirt is what your vacuum cleaner picks up.
I agree with that. We do have one question. Let me see. Going back to your pie chart, Mike.
Mm-hmm.
Someone had asked, uh, is there a source for your pie chart?
Oh, you can probably find that. That's a really common pie chart, and so many of the sites that are out there about soil. I mean, you can go out to the UC website and find it, and lots of other websites. That's kind of a common tool that just kind of helps at a macro level to understand the composition of soil.
You did say something that also reminded me about not watering over plants or over watering plants because they need oxygen in the ground. So when I water, I think about not drowning my plants because
Absolutely, yeah, they will drown. They
they,
need oxygen. They're just like
yes,
us.
I'm always excited like when someone's like, "What?" and I'm like, "Yeah, they can drown." They're like, "No."
Yeah.
So I find that interesting. We do have one question
Mm-hmm.
from Nancy. No tilling. Does that apply to shallow turning of soil?
Um, there's not a need to turn soil, um, and this is something that I spend a lot of time working at our demonstration garden here in Walnut Creek, and it was interesting to me that we did use a broad fork when I first got there, and in fact we did double digging before that, And what we have done more and more and more is less and less and less. Like I had mentioned kind of in the beginning of this presentation, that sometimes less is more.
Yeah.
And what we're finding is that very simply by doing a chop and drop method, so that at the end of a season we just chop and drop the plant materials. We put a light cover of compost over that, and then something that we've discovered, that if you happen to have a coffee roaster anywhere in your vicinity, coffee comes in very large burlap sacks that are actually a wonderful cover, a mulch, if you will, for your soil. And the coffee roasters love you to take them because otherwise they have to take them to a landfill. So what we do today is we actually just chop and drop. We put about an inch of compost over it, and then we cover that bed for about 2 weeks with a piece of burlap. And you will be absolutely amazed because when you pull that burlap back, all that material has decomposed and you have composted in place with a whole lot less work. And you've got really good, rich soil. Our soil at the demonstration garden now is running close to 15% organic material.
That's great. Um, and Nancy, I am also a master gardener and a gardener in general. And when I am working in my garden, there's some areas that are really worked really well, like kind of what Mike was talking about. And I have other areas where I know we've driven our truck over that I need to dig up a little bit just so I can get some air in that top layer and try and get some water into that soil later on. So for me, that's a little bit of work I need to do only in certain sections.
Yeah, absolutely. I mean, like I had mentioned that, you know, especially if you're moving into a new home or a new
Oh yes.
subdivision. Yeah, I mean that you may have to do a little tilling there to begin to break that soil up.
Yeah,
But
that
you
that
know,
new that new construction soil compaction can really damage your
yeah, that could be
damage it.
really tough.
All right, we have another question. A question about forest products. I know, Mike, your
Mhm.
talk wasn't about potting soil, but how about the potting soil and potting mixed? Are they forest products as well?
Um, for the most part, most of them are also usually have an additive of perlite or vermiculite that are added to them, which are basically pulverized lava, and that helps with drainage because that's the important piece with with any container planting is you want good drainage. I mean, you've got a pretty good mass of soil there, and usually you've only got a very small little drainage hole in the bottom of your pot. So, Lauren, as you just mentioned, you don't want to drown your plants, and that can
Yeah.
happen very easily in a pot. One thing I do recommend to people is there is nothing wrong if you have access to good quality topsoil. 25% of that potting soil mix can be good topsoil. And that's a great way to introduce some of that mineral and those essential elements to your container plants.
Yeah. All right, we have time for one more question. And what's your thoughts on rock mulch to armor your soil?
Um, I haven't done a lot with it, um, and I'm sure it's fine. The only thing I would say is that your microbes and your earthworms and things of that nature are not really happy with rock. I mean, they prefer the organic materials that they start breaking down. Now, in part of that process, they do also ingest part of those minerals. But if you're really trying to grow the population of microbes and earthworms in your soil, I would stick with organic materials. Rock dust and things like that is not organic. It does contain minerals, but it's not an organic material.
Great. All right. Mike, thank you so much. That is all the time we have today.
Thank
Thank you for
you.
participating in Healthy Soils Week. For those of you that have joined us and have more questions or are joining us later, you can get in touch with your own local UC Master Gardener volunteers like Mike and pick their brains on how to improve your soil in your area, what types of mulch are good for you. If you have a specific goal that you're trying to reach, I'm going to drop in the chat how you can find find us and how you can get in contact with all of your local volunteers. We do have more upcoming fancy Healthy Soils Weeks talks. Tomorrow we are harnessing the magic of the soil food web, which Mike knows all about. And if he had 3 hours to tell us all about it, I'm sure he would have. Mike is full of information, and we're so happy that you came and talked to us today and told us all about the composition of soil. I've learned so much from you. I'm going to add some more things to my list of things to do, like move some leaves around and actually feed my soil instead of resting it on an empty stomach. So thank you so much, everyone. Mike, have a great day.
Thank you.
Bye.